In today's video, we are going to build this 3000 watt off-grid mobile solar system. I'm going to do a step-by-step video so anyone can do it without experience. To have a small backup system like this is important. Any second we can lose the power, but if we have it, we can power the most important appliances during power outage. It is going to take about an hour to build, but once it's done, for the price, it will be more powerful than an all-in-one unit. Welcome back to my channel Off-Grid with Laszlo and Renewable Energy. Today we are going to build a mobile off-grid solar system that we can take anywhere we want to, use it on a construction site, in the yard, or just powering some of our appliances in emergency. This can be done in multiple ways, like if we secure everything to a hand truck, a stand, or even build it in a trailer. I picked up this metal stand because once I'm done with this, I'm going to install a lot of other components to make it a very powerful backup station. I decided to go with this EG4 3000 EHV 48V off-grid inverter that also a MPPT and battery charger. Comes with a LCD display and button operation. Rated output power is 3000 watts. MPPT startup voltage is 120 volts. Battery to inverter efficiency is 94%. Suggested charging current is 80 amps and PV array open circuit voltage is 500 volt DC. Package includes black and red 6 feet 4 gauge battery cables, 125 amp rated DC circuit breaker, ADI bracket, manual, communication cables, Wi-Fi stick with remote settings adjustment, and the inverter. First, let's secure the inverter to the top section of this panel. We can mount the inverter on any non-combustible material vertically that is strong enough to bear the weight of the inverter. Be sure to distance other objects and surfaces 19.7 inches up and down, 7.9 inches on the sides. Next, we are going to secure this DIHOOL solar disconnect switch 40 amp DC circuit breaker with surge protector. This is a IP65 waterproof box with 4 solar disconnect switch, 4 strings in and out up to 1000 volt DC. We also can use a solar disconnect switch like this without the safety features and turn the DC power off anytime we want to or necessarily. Since we have to remove the cover to able to secure the unit on the wall, I just spent some time to secure all the connections before I mount it. If we build a stationary system, we can secure the disconnect either close to the solar panels outside or close to the inverter as well. Next, I'm using an outdoor electrical box that needs a little modification. This is where we're going to secure the DIN rail and the cable glands. Once we secure it on the wall, we will mount the 125 amp DC circuit breaker. secured all the components on this side. Now we are going to install a 200 amp electrical panel on the other side of the wall, so we can turn on and off anything on the AC side. As I mentioned earlier, we are going to install a lot of other things on this stand. If you build one just for emergency, a 30 amp circuit breaker is more than enough. We can start wiring the components together. This is a picture of the bottom of the inverter. As we can see to the right, that's where we can connect our battery cables we received in the package. Let's remove the cover and connect the red cable to positive and the black cable to the negative terminal. We are going to use this 10-2 copper building wire for AC out, and right now we are going to install a cable gland first. Next, let's install the PV wires. Remove 10 mm or 0.4 inch of the insulation sleeve from the positive and negative conductors. For DC wires, I strongly suggest to use ferrules for two reasons. First, if we secure DC wires directly with bolts, the bolt can damage the thin wires. Second, if we use the right size ferrules, that makes the wire stronger at the connection point, so able to handle more amps as well. Most of the time, not the wire is the failure in the system, it is the connection. The battery and PV cables are connected. Now let's use a 10 gauge wire for AC out. Unfortunately, the ground connection point is designed outside of the service panel, so we are going to bring it in and out at the next service hole. We also have to crimp a wire connector to be able to attach it with a bolt. We are going to remove the insulation sleeve for the same length, 10 mm or 0.4 inches at this location, and we are connecting the black wire to load and the white wire to neutral terminal. For AC in, over here we are going to install a 10 gauge generator cable, and we can charge the batteries if we have to. If someone building it for an emergency only, for this location it is possible to connect a 10 gauge extension cord with a plug and charge it from the house as well. We connected all the wires to this inverter. Now let's secure the cover back and install the 125 amp DC circuit breaker on the positive wire between the inverter and the battery. We can easily mount the breaker on the rail by pushing it on. After we measure out the length of the cable up to the breaker connection point, cut the cable, remove the insulation with the proper tool and secure it. In the description I'm going to have a couple of videos related to this subject, like how to clean secure wires to different connectors and terminals. Please check it out for reference. Everything starts there. Let's secure the cables to the wall, they look a little bit nicer, and connect the PV wires to the breaker box as well. If someone decides to buy this solar disconnect breaker box, I will also have the link for it. The MC4 connectors close to the wall will connect to the inverter and the outside ones connect to the solar panels. Now let's work on the AC side and connect all the wires to the panel. First, we will connect the wires from the inverter and use a 30 amp circuit breaker. In this main electrical panel we have 4 bus bars. One for L1, L2, these are for hot wires, one for neutral wires and one for the ground. We connect the red and black wires to L1, L2, white wires for neutral and green, bare or green with yellow strips to ground bus bar. If someone is not sure how to connect these wires, please contact an electrician. We have to remove the insulation from the wires long enough to be able to connect each wire to their dedicated spot. We can bend the wire in any direction using a plier. Measure out the length of the wire to the connection point, cut it and secure it. Once the wire is connected, let's pull on it a little bit to make sure it's secured properly. At this location, we are securing a 2-gang outdoor box and install 2 GFCI receptacles with 2 designated 20 amp circuit breakers. In this way, we can separately use them and take advantage of the full 20 amp they are rated for. Whenever we are removing insulation on a wire for long distance, I found it easier to step on it and pull it off. Here we are connecting the wires the same way, bare wire to ground, white wire to neutral, and the black wires will be connected to the breakers. We are not connecting the red wire at this moment. I suggest to install wires with extra conductor to each location in the house as well. Just in case anything happens with one of them, the only thing needs to be done to connect the other wire at the receptacle and the panel. We wired all the components together, let's connect the battery as well. We are connecting the black cable to battery's negative and the red cable to battery's positive terminal. This is the EG4 LLS 48V 100 Ah server rack battery, have a life cycle of more than 15 years with a 80% depth of discharge daily. Charge and discharge current is up to 100 amps. UL listed, parallel up to 64 batteries and comes with a LCD touchscreen. Supports closed-loop communication and enjoy the 10-year warranty. Let's turn it on and see how it looks. As we can see, the state of charge is at 98%, so let's turn the inverter on as well. After turning the circuit breaker on, we have to turn the small switch on at the bottom of the inverter. Everything looks good so far. We have the 120 volt present. Now we will power up the breaker panel. Let's turn on the main breaker, followed by the 30 amp breaker for AC disconnect and the 20 amp breaker for the GFCI receptacle. To make sure everything works properly, I'm going to use a heat gun to test the inverter. Let's turn it on and see what happens. As we can see, we are discharging the battery between 550 and 600 watt. Now let's set up some solar panels as well to see if they are able to charge the batteries. To this inverter we can connect a string up to 5000 watt and 500 volt DC. These panels are 225 watt each. I'm going to connect 6 panels in series. To connect panels in series, just simply connect the MC4 positive plug to the next panel's negative plug. Once all the panels are connected, we have to check open circuit voltage before connecting it back to the inverter. Right now this is 201.3 volt, so safely we can connect it to the breaker box. Let's turn the circuit breaker on and see if there is any change on the display. The solar panel icon just showed up and the battery is charging. If we decide to build a system but we don't know how large should be, build a small one like this for emergency or scale it up later. I strongly suggest to buy the type of inverter and batteries that is capable of scaling. As we can see, purchasing a few components and connecting with a few wires together, we can use the energy anywhere and whenever we want to. If you secure the inverter with 3 bolts on a hand truck, attach the battery on the bottom with a strap, and there are pre-made electrical boxes with glands for breakers, we just attach one for each breaker. We can use a 10 gauge extension cord splitter like this for AC out. Just cut the plug and connect it. We can store it in a closet, use it on RV, or just access to power anywhere we don't want to drag a 100-foot extension cord with us. For emergencies, we don't need solar panels. We can connect an extension cord with a plug and charge it from the grid. Today, this is what I wanted to share with you. I hope you liked the video. I want to thank for everyone who's already subscribed to my channel. If you haven't done it so, please do that if you like. If I missed anything or I made a mistake, please let me know, so I can correct it. If you have any questions, let me know in the comments as well. Thank you very much for watching, have a great day and see you in the next one.